Hi, I'm Dave Bartlett. I'm sure some of you know me. For those of you that don't, I'm the Technical Director for Medhurst. So I look after predominantly a lot of the teams that come into schools, colleges, universities. I look after a lot of the cloud infrastructure that we do. I also specialise in things like Hyper-V, VMware, shouldn't be say that here, but anyway, and things like storage, networking, virtualization and hybrid cloud technologies. So that's my background. I've been with Medhurst for 7 or so years in this role. So let's just have a look at the agenda for the next sort of hour or so, just shy of an hour, I think. So we've heard a little bit from Mark about Azure, which I think was really useful to hear about. A lot of people sort of heard of Azure. You see it on TV a lot, cloud this, cloud that, cloud the other. And to quantify what Azure is and what it can do for you is a really important step, I think, today. So that's one of the things we're going to be doing. And the way we're going to be doing that, and again, Mark alluded to this, we're going to talk about extending your networks, your school's networks into Azure. So we know Azure's up here. We know your school's networks are down here. How do we link the two up so they become useful and they can communicate? So we're going to talk about that. Secondly, we're going to talk about data recovery, disaster recovery. Mark's already talked about the Azure backup. This is quite a tech-filled demo, so we're going to sort of jump around a little bit to different servers and see how all of this technology works and how we can use it. Within data recovery, we're also going to illustrate another couple of things. We're going to use Veeam. Who's got Veeam here? Just out of interest. We all like Veeam? We're all happy with Veeam? Great product. Okay, so we're all using it on site. We're going to learn how we can leverage Azure to get our Veeam backups off site. Okay. And then the third item we're going to look at within data recovery is the Azure Site Recovery piece. And that's enabling you to have virtual machines replicated from your on-premise network into Azure, and then you can fire them up when you need them. So hopefully that'll all work. Okay, Azure Site Replication. And then just as a sort of an illustration, as Mark highlighted, we can put VMs into Azure. Microsoft will supply the operating system, the hardware for us, the power, the connectivity. So why don't we use this platform for perhaps something to do with System Center? Operations Manager is a good fit, something that needs to look after your environment. If you put it outside of your environment, it's going to be a lot better suited to look after that. It doesn't rely on anything within your school's environment. Then we're going to do a couple of things on shared VHDX support. Who's heard of shared VHDX support in Windows 2012 R2? So we've got one person. Okay, brilliant. So just going to introduce you to some of the things you can use that for. In this example, we're going to talk about file services. What happens when your file servers go offline? How can you bolster that? How can you make those more available? Okay. And also we're going to talk a little bit about SMB multi-channel. Who's heard of SMB multi-channel? It's something now that's built into 2012 and works out of the box. Something that you need to be aware of. It's something that happens automatically, and by knowing about it, you may be able to build your networks accordingly to make use of it. So we're going to take a look at it. And obviously the file services clustering we're going to take a look at too. Right, so extending your network into Azure. So let's look at your typical on-site premise, how your networking is set up. So let's take the main school building. We've got a lovely building. We've got some switches in there. We've got some PCs, some printers, some servers. They all connect together, and you might put them on that network range. So you can get 254 clients onto that network range. Then the building gets overcrowded. We're running out of space. So what do? We go and build another building. We give that a network range, and we connect that back with more switches back to our main school infrastructure. And the same is true as we carry on. Okay. So eventually you'll end up with, I'm sure most of you have, a lot of different buildings all linked back up into a core infrastructure, and there are resources out in those different buildings, probably things like workstations and things like that rather than servers, but nevertheless it's an extended network. Other connectivity, so what else have you got? You've got an internet connection. So just out of interest, who's got less than 100 meg at the moment? Okay, that's pretty good news. Who's got 100 meg? Hey, right, who's got more than 100 meg? Right, I'm interested now. What have you got? You got 200. Any more? Any better than 2? Gig. Oh, you're just showing off now, aren't you? So I think that sort of shows that as time increases, we're going to see better and better connectivity into into schools as we have done over the last few years. So on the internet we have this Azure platform, okay, that we've all been talking about. That's linked to the internet, and Azure can then be leveraged as an additional site. That's what I want you to think of Azure as in this context. I want you to think of Azure as a site that's connected to your school network that you can go and use. And we do that by way of something called an IPsec VPN. So it's a very secure way of linking two sites together or two networks together using some pretty hardcore encryption and enables you to then pass traffic between the two networks. Okay, so that's what we end up. We'll give that Azure network an IP address or an IP address range, and then we can go ahead and put things into that range. Now, we talked about Azure having around the 17 regional data center sites. Think of each of those data centers as a site, if you like. Think of those as sites that you could have services at. You might want them in East Asia, you might want them in Europe, you might want them elsewhere. And you can create your subnets within these sites and link them to your school. And they're directly available. You can ping the things in there, they're ready to use. So what I want to do is just show you very quickly around that piece. So let's just nip into our Azure portal. Is anybody logged into Azure? We had a couple of people, I think. So this is the management tool that Microsoft provide for you to manage your Azure technologies. Okay, there's a beta site coming out. They're revamping it at the moment. It supports most technologies. There are some things it won't let you do now, like site recovery. That's coming soon, so on and so forth. So let's talk about this networking. Let's get that straight first. Let's make sure we understand how that works. So I go ahead and I come down the list here and I find my networks button, okay? And then if I look over and to the right, I've got two networks set up, and they are two geographic locations. There's West Europe and North Europe. I think West Europe is the Netherlands and Northern Europe is Ireland. Okay, so I've got two networks created in those two different data center arenas. Okay, so the network we're going to be using today is the West European network, so that's the Netherlands network. What I can then do is I can go and create my local networks. Okay, and these are the networks that you'll have on site. You might have a single subnet, you might have a lot of VLANs, you might have lots of different buildings that may require access through VLAN technology up to Azure. So we need to let Azure know what we've got on site. Okay, and I can go and edit that, and I can the one bit of information that's really crucial here is the VPN device IP address. So my VPN endpoint in this case is a Cisco firewall, and what Azure are wanting to know is what's the IP address of that public-facing firewall, so we can make that secure connection to it and get the ball rolling. Okay, so that's what I've put in there, and here is the address space that potentially I'd like to use. Okay, we're looking at the C4L network at the moment. I should have really done this one. So the network range that I've got back at Parkgate, which is where our offices are, is a 172.10.10 network. Okay, that's what we're using, and the VPN device endpoint, the 94.30 address, is the public-facing IP on my Cisco firewall. Okay. And that's where I set my address space. Now, once I've got those things set up, so I've got my virtual network set up now, so I've got my West European network, I've got my local network set up, so I know what's on site, what I'm going to want to pass to Azure. I can also then set up DNS servers. So when I create virtual machines in Azure on this new connected network, not only are they going to get an IP address in the range that I want, they're also going to point straight to my DNS server. So we're really cutting down that administrative thing of having to plumb all this information in. That's all done for you when you build a virtual machine. And then once you've got all that set up and the thing connects, you'll notice on this dashboard page, we can see that the West European data center is on the left there. We have a gateway VPN connection back to my Parkgate device. And then you can see in the resources below the different things I'm using on this particular Azure network, my Netherlands network. So I've got here, straight away, we can see down here, I've got an Azure SQL server running 2012, excuse me. And I've also created an Azure Operations Manager server. Who's used Operations Manager here before? Okay, so it's estate management, looking at things like alerting, monitoring, what should happen if things go wrong. We need to know about these sort of things. So I've got an Operations Manager VM in Azure that's monitoring my internal network. Okay, so if my Hyper-V cluster fell over, I wouldn't have to worry about monitoring it. If it was on premise, perhaps I would do. Okay, and I've also got one called MCL Azure Veeam, and that's just a Windows server that we're going to use as a target repository to start sending our Veeam backups offsite in a little while. So I've got some useful information here. I can see how much data's come in, I can see how much data's come out. I can also see the virtual gateway address that Microsoft give me, and that's what I am connecting to with my Cisco firewall. Once you've created all of this, you'll notice there's a VPN device script button there, and quite straightforward because obviously you're not going to have control over the Azure firewall platform, so you tell them what you want. Okay, so for example, we could use a Cisco, an ASA appliance with this version of software. I hit on OK, and what it will do is it will give me the lines I require in my Cisco config. Okay, and we'll support things like Juniper as well. It supports Microsoft RAS. So very quickly, they give you, based on the information you've given them, your details, you plumb them in, your connection's made, and then the two sites are connected. Okay, any questions on connectivity at the moment before I move on? Is everybody happy? Yes?
Was that right, or was it only 3 choices?
3 choices.
Yeah, Cisco, Juniper, and Microsoft.
They're the 3 that are on there so far. But as Mark says, this will always get bolstered over the weeks and months. There will be more and more support in there for different vendors as we go on. Right, so going to move on to backup, disaster recovery. The bane of people's lives. It's a horrible, horrible thing to have to do to protect your VMs. It's been a lot better since we've got to virtual machines. Would you all agree? Now we're in the virtual world with products like DPM and Veeam and other products, but being able to back up a VM now as opposed to having a physical bit of tin that you're backing up the C drive, the system state. It's very easy to get things back now. So I just wanted to talk very quickly about the 3-2-1 rule. Okay, and this was written by a guy called Peter Croft, I think his surname is, an American guy. He said there are 2 sorts of people. There are people that have already had a storage failure, and there are people who will have one in the future. And that really means that if you own something that can fail, the average or the probability will say that that thing will fail eventually. Okay, so this is where this 3-2-1 rules come from. So, number 1, have 3 copies of your data. Okay, so that's production data. That's what's on your production storage, whether that's a SAN, a standalone server, or some form of other storage. Okay, that's number 1. You then have to have a copy of that data. That's number 2. Okay, and that's a copy of your production data. The third one is a copy again. Okay, so we've got 3 copies. Now, the reason we do this, let's say we've got a file, we've got a server here and another server here. This one has the production data and we're doing the backup. They're the same sort of hardware, and let's say there's a 1 in 10 chance this one will fail, which means that this has a 1 in 10 chance of failing. So essentially, if you put those together, it's a 1 in 100 chance that kit will fail. If you add a third option, then you've suddenly made that 1 in 1,000. So it's just an odds game. Okay, so the more copies of data you have, the more likely you are to keep it. Okay, store the copies on 2 different types of media. So this is the 2 rule. And this really can be anything that your backup product supports. Okay, so here we've illustrated something like a drive enclosure. It might be a tape drive, something like an Ultrium device or an autoloader, or it could be something as straightforward as a USB disk. Okay, so making sure that you haven't got your production data and your backup data on 2 different V disks in the same SAN. That would be a very bad idea, because if you lose that SAN, you've lost all of your data. So keeping your data on different types of media is the way to go. And then the one part of this is keep 1 backup copy offsite. All right, so there are a lot of different vendors that do backup software out there which can offsite. Today, we're going to be looking at how we can use Azure to go ahead and do that. Right, does that all make sense? Any questions so far? Good, right. So, Azure backup. Let's have a little talk about Azure backup. Anybody? So, we asked earlier, anybody used Azure backup in anger yet? Anybody had a look at it? It's really familiar. It looks very much like Windows backup. In fact, it's built on Windows backup, so it's not an interface that you're going to have to sit down and learn. It's very obvious. So things you need: an internet connection, so you can actually get to the Azure platform. And then in Azure, you need to create something called an Azure Backup Vault. And that backup vault is your lump of storage that you're going to use to back up your data to. And you make a choice as to what it's called and where you want to locate it. Okay, it's quite as straightforward as that. Other things you'll need. you'll need the Azure backup agent. So this is a very small 40 meg file that you install on the server or servers that you want to protect. Okay. You will also need something called the Vault credentials. So when you're backing up to Azure, you're not doing this over a VPN, you're doing this over the internet. So security is a big issue here. So by having a Vault credential file, which is an SSL encrypted hash algorithm, if you like, we can assure Azure of our identity. And you can download that Vault credentials file from the Azure portal. Right, so what I want to do is very quickly, and let's hope it all holds up today, do a few demos of Azure backup. So if I go back to my Azure portal here, and I come back to my recovery services, and I'm going to go and have a look at my Innovation Center off-site backup vault. Okay, I'm protecting one server at the moment. Here's my landing page, and we can see I'm using about 0.06 of a gig and backing up one server. Here on this landing page, we can see we can download the backup agent for server or System Center Data Protection Manager. Don't forget, you can integrate this into DPM now. So who's seen that? You've got Cloud Protection, Azure icon in DPM. Have we all seen that? That links you straight into the Azure cloud, so you can off-site using DPM into an Azure cloud. The Vault credentials I spoke about are there. So if I need to download them onto another server, because don't forget, you can have multiple servers connecting into this one backup vault and storing their data there. Okay, so if I want to get those credentials, I download them, I store those on the server along with the installer, and I go ahead and install it. So, there we go, it's just offering those credentials to me now. I can nip in and have a look at my protected items here, and it just shows me the areas that are protected on each server. There we go, so I'm only protecting one server at the moment, and I'm protecting a file, folder structure, and we can see there I've got 12 recovery points. If I look at servers, it shows me the server that I've registered. So what I'm going to do, very quickly, I'm going to go ahead and register a server, and I'm going to show you how this process works, show you how the backup restore process works. So the server I'm going to use is just a straightforward 2012 RT box, if I can find it. There we go. Okay, now what I've done, okay, you probably wouldn't go ahead and create your data folder on your desktop, but just for argument's sake, I've done that today, and I've got some stuff I want to back up. Thing 1, Thing 2, Thing 3. So, things I'm going to need, we've talked about it already. We need the Mars agent installer, which is the Azure Recovery Services agent, which we'll go ahead and install. So it wants to know where I'm going to put it and where to put the cache. It will check that I'm connected to the internet, make sure I've got .NET Framework and PowerShell available, and then we go and install it. So while that's getting on with it, we need to make sure that we've got our Vault credentials file. Here we are. We can see it's got a sort of a date and time from when I downloaded it, when it's valid. And I need to have that available for the next part. So once the installation is completed, in a moment, hopefully. There we go. I've got a little button there that says Proceed to Registration. So I'm going to click that. And the next thing it's going to ask me for is my Vault credentials. So I'm going to go and browse to where I've stored those, plumb them in, and it will validate those. So it's now going to talk to Azure, that particular backup vault, with the credentials I'm providing, and it should tell me that everything's okay and I'm good to proceed. Right. Now, while it's doing this, I'm going to, as I say, I'm going to nip around because I don't want to be sitting here waiting for things to happen. So while that's coming along, I'm going to show you the server that we are backing up. So it's a server called IC-AC. This is back at our Innovation Center. Is that big enough, everybody? Can everyone see that all right? I know I'm right in front of the laptop here, so I just want to make sure you can all see. So here we are. We're looking at Azure Backup in action now. Looks a lot like Microsoft Backup, doesn't it? And what they've done essentially is squirted the Azure code into this. So what I've gone ahead and done is I've done a scheduled backup job for this server. Okay, so we'll go and take a quick look. And again, don't forget all this is stored in Azure, so this is not local. The configuration is up there. It ties in when you log in. I can go ahead and modify the backup I've done. So we'll just have a quick look and see how this works. So first item, what am I protecting? Do you remember Mark was saying that this is a files and folders protection level? So I can go in and I can select the files and folders I want to protect. Straightforward as that. I can exclude various things if I want to, so I might not want to carry an MDB file that's 80 terabytes in that share. I might want to exclude that file, so I can do if I want to, something like that. I can go ahead and define my retention ranges when I want this process to run 3 times a day, at 10 o'clock, at 2 o'clock and a 6. That should catch the morning changes, the lunchtime stroke afternoon changes, and then by the end of the day, it backs up again. Okay, and I've asked it to keep 40 days worth. So that's largely it. And because I've already registered this server with Azure, it assumes I'm going to use the Azure platform to put my data on. Okay, so what I can do now, let's take a look at the other server that we just installed the agent on, which should all be, no, still going. So let's go back to this one.
Quick question while you're waiting for that. You don't have to have VPN in place as your backup as well.
No, you don't. No. Yeah, it's an internet-based service. That's why you have those secure credentials, why you have those Vault credentials, because you need to authenticate yourself over, essentially, an SSL connection. So you don't have to have a VPN in place for this. So what I can do now, when I want to recover data, it's exactly the same as you do it in Windows NT Backup. I can go ahead and select the server I want. I can go and browse my files. I can select the volume that my files are stored on. It'll go away, have a look what data's in my backup vault, and allow me to select that data and restore it. I can also go back to any day that has a bold figure. So the 27th, I've got data on those 2 recovery points. So if I come back to something like yesterday, we can see the 3 backups there. I can look at the 2 p.m. backup and I can go and see what's available. And there should be sort of 3 files in there. There we go. So I've got the ability now to go and recover those. So let's do that. Let's just nip in. If I go to my desktop folder where my data is, and I'm going to delete the picture of me doing my homework. There we go. Let's get rid of that. So that's gone. To restore that, as you can imagine, we select it in the backup. We click next. Where do we want it to go? Original location, somewhere else. What do we want to do if it exists there already? Do we want to make a copy? Do we want to overwrite? And do we want to restore access control list permissions with that particular file? Okay, then we hit recover, and as you can imagine, it's now querying the vault and it's going to pull that data down and restore it. Now, if the other one's now working, let's nip back here. Aha, that's not the sort of thing you want to see on a Microsoft demo, is it? Well, let's leave that one. That's why I had 2. It's worth mentioning that when you recover or when you register another server with the same backup vault, let's say server 1 is already pointing to that backup vault, you go and register server 2, you can restore server 1's data on server 2. So it doesn't matter where, getting your data back from the same server is fine, but what if that server's not available? It's as easy as squirting a copy of 2012 R2 onto a VM, putting the Azure backup agent on, providing the credentials, and then you can browse any server that's stored data in that vault. Okay, anybody got any questions? Yes.
That client that you're using, is that part of that Mars installation, or is that something else?
So the question, the client installation, or the Mars installer, is the Azure recovery services for Windows. Now, there are other agents, if you're going to integrate, when we get to site recovery later, there's another agent that we use to affiliate our Hyper-V or System Center environment with Azure as well. But this is purely file and folder backup, and it is what it is. So you can restore files and folders, backup files and folders, and more importantly, restore files and folders from any computer to any other computer that has the agent on it. And there we go, so that's finished. If I look back at my folder, there's my homework back again. Right, okay, moving on then. So we've talked a little bit about Azure Backup, how it works, what we can do with it. Really handy for just getting that critical data if it's file and folder format offsite. Right, so let's talk about integrating Veeam with Azure. So we're all pretty familiar with Veeam. So I'll just go over the process very quickly. We have a Hyper-V server or servers, it might be a cluster of, and those Hyper-V servers have VMs running on them. We go out and buy a piece of hardware for our Veeam server to run on, and we have a lump of disk attached to it, which might be iSCSI, fiber, might be direct attached, it might be anything. And then what we can do is we can go and store our VMs, or we can back up those VMs and they sit in that Veeam data store. Okay, go back to the 3-2-1 rule, that's two copies of our data now. So what we do to achieve the third, we go and put some form of hardware in that's got storage, and we copy again to that piece of hardware. So our VMs are then backed up to that as well. There you go, that's your 3. We've also satisfied our 2 rule. So we've got 2 different types of media there, got 2 completely separate hard disk arrays. To satisfy the 1 rule, why not take that lump and put it in Azure? So you haven't got to worry about your hardware anymore, your disk storage, your Windows licensing. You just need to worry about getting that data onto that server. And that's what we're going to sort of show how we can do very straightforward here. So if I nip over to our Veeam server now, okay. Now, I've already got, and I'll just whip through this because I'm sure pretty much most of you here have used Veeam. Veeam's 3 things. It's a coordinator, it's a proxy on the hypervisor that you're using, and it's a repository. So the coordinator says, Mr. Proxy, get the data from that SAN and send it to that repository. That's essentially how Veeam works. Now, I've got an on-site repository here, which is just some local storage that's presented to this Veeam server. I want to make use of my Azure recovery site now. I want to actually be able to start using that. So what I've gone and done, if we nip back to the Azure dashboard here, 2 seconds, sorry. I can nip up to my virtual machines tab here, and we've got a virtual machine in here called Azure Veeam, okay? And that was built using the Azure platform by clicking on New, Compute, Virtual Machine. I've done it from a gallery, essentially, and I've gone and picked out the image I wanted, so a 2012 R2 server, and it gets built for me. It's on the 192.168.16 network, which is affiliated to my site back in Parkgate, ready to go. So it's very, very straightforward and very quick to get that process up and running. Okay, so that VM is up there. It's a 2012 server, it's in Azure, and we want to use that to store our VMs. So what we're going to do, we'll nip back to our Veeam server. The server in question was called MCL Azure Veeam, so I need to add that now as a repository, so I'm going to go ahead and do that. So I'm going to call this Azure West Europe, because that's where my Azure site is based. I'm going to be connecting to a Windows server. It won't be this server, it'll be a server called MCL Azure Veeam, which I've already popped in there. If I hit populate, that goes away, and it looks at the server in Azure, and it's working out what disks it's got and where am I going to store my backups. So we'll look on the F drive there. That's the one that I provisioned for my backups. F for Veeam, nice and easy to remember. So let's go ahead. Ooh. So let's select the F drive, and we're going to use the backups folder, very similar to adding a normal repository. vPower NFS, that's the technology that allows the data to stay in the backup and get presented to Hyper-V. So when you're doing things like instant VM recovery, you can recover the VM very quickly. It still has its data in the cloud, but then it trickles down to you as and when throughout the day. So the important thing is getting the VM up and running. There we go. So very straightforward. I've now created an off-site repository now. So now I've got something there to use. Let's go and back something up to it. So we'll go to the backup tab. Let's create a backup job. I'm going to call it send it to Azure. Okay, and obviously we don't want to be sat here watching a 50 gig VM going up over our link. So what I've done is I've created a machine called Important Server. That would be quite a good name. It's got a hard disk, but I haven't installed anything onto it. Just for the sake of time. It's quite boring watching a backup run, as you can imagine. Now, on my storage screen, I need to now go ahead and choose my Azure West Europe storage repository, and then I can go and work out what I want to do with my retention policy and various other things. I would suggest by nipping into the Advanced tab if you're using Veeam, and if you're using a WAN target, go ahead and set your storage optimization to WAN, so it sequences it up to Azure properly for you. It makes best use of high latency links and slower links if you have those. Okay, and then I've got the usual sort of choices. Do I want to quiesce my transaction logs? And do I want to have guest file system indexing? Do I want to be able to restore files from the Veeam portal as opposed to the console? I can schedule the job to run when I want. I won't do that. I'm just going to go ahead and run the job. Okay, so quite straightforward. I mean, you can see that's taken me less than 5 minutes to get that set up and working. The Azure setup itself, you've got to have that in the background first. Make sure you've got your network, so you're affiliating your site. You've got to make sure you've got a VM up there, or something similar that you can send data to. I've used a VM here, because it's very easy and very obvious to do. So let's have a quick look at the job, see how it's doing. This should be nice and quick. So we're processing important server. It's doing its little CSV snapshot. So it's snapshotting the VM within Hyper-V, and then it sends it all off to Azure. Don't forget this will work for VMware as well. So those of you that do have VMware, you can back it up and then send that to Azure as well. So there we go. It's just saving the XML file associated with the VM. It's just updating its own references and documents, and then it's going to try and send this C drive up. There we go. That's done, and that's largely it. Okay. Very quick because the C drive had nothing on it, but you get my point. If it was a 20 gig drive, it would take however long it takes to shoot 20 gig up your link. Right. So what happens now if we lose a VM? Let's use the Azure platform to get our data back. So to do that, we're going to nip over to our failover cluster. And I'm going to take that important server and I'm going to turn it off completely. I'm going to remove its cluster configuration. I'm going to go to Hyper-V, the Hyper-V manager, because it will still be there on node 1, I believe. There it is. And I'm going to delete it from Hyper-V. So that's the reference in the Hyper-V manager. And then just for belt and braces, I'm going to nip into the cluster shared volume where the data elements of that VM are stored, important server, and I'm going to delete that as well. So I think we can all well and truly say that VM has had it. Okay, so we're in disaster recovery scenario. What do we do? So we nip to Veeam and we do pretty much what we would do on site. So we can go ahead, select our restore job. We're going to do an entire VM here. Click on next. We want a VM name, so I'll start typing in important server. I can go ahead and select different recovery points if I have them. Here we see we've only got one. It's a full backup because I've only done it once. Okay, but I can select the recovery point that I want. Where do I want it to go? Well, original location would be lovely. I might not want to do that. I might want to put it on a different Hyper-V host. I might want to restore that data to a file and folder so I can put it on a USB disk and take it somewhere else. Okay, and do I want to power the VM on after it's been restored? Yes, please, that'd be lovely. Okay, so we'll hit finish and this restore job will run. So while this is running, what I'll do is I'll also, because it happens pretty quick, we'll nip back to the Hyper-V manager. And what we should expect to see is that VM appear very, very quickly indeed. There we go, important server. And at the same time, if we look at failover cluster manager, yeah, it's already done it and it's powered it up for you. Okay, very, very, very useful piece of technology. And just thing to remember on that was very, very quick. If you've got a lot of data on your disks, that's the thing that's going to take the time to come back. But as I say, don't forget with instant VM recovery, the data doesn't get restored immediately. Your VM's up and running. People can get to it, albeit it's going to be a bit slower. And then when you're happy people are logged on, there's your, migrate to production. Then your storage starts to trickle down from Azure into your on-premise infrastructure. Okay, any questions?
Quick question.
Yes.
Sorry. You said that you could use this for VMware or for Hyper-V.
Mhm.
What are the specifics?
Is it something like Zen or Zen server? I have to be honest, I don't work particularly with that technology. I don't know. I will find out for you though, if you like. If you can come and have a chat to me afterwards and we'll see what there is. Okay. Anybody else got any questions so far? Brilliant. Okay. So the next thing we're going to look at is site recovery. This is a really big one, really, really useful. So in essence, has anybody used replication here? Anybody replicating anything at the moment? So we can do that out the box now with Hyper-V. We can do it from cluster to host, from cluster to cluster, host to cluster. We can also do it with Veeam. We can also do it with things like System Center, Virtual Machine Manager. So let's talk about replicating virtual machines. Let's talk about getting the machines that you deem absolutely critical. If you were to lose them, if you lose them, it'd be a pain. Let's get them to Azure and have replicas of them up there to use when we need. So we create something called a site recovery vault. I've created a site recovery vault in the West Europe data center, and it's ready to go. So what we then go ahead and do is we run something called the Azure Site Recovery Configurator, which is a little file which tells us, or tells Azure service, which Hyper-V servers we want to protect against. Again, there are vault credentials that you specify, so it's a secure connection, and then you decide which machines you want as candidates for sending to the site recovery vault. So once you've put the credentials in, you have a connection between the Site Recovery Vault and Hyper-V. The Site Recovery Vault knows of the servers that you've got running in Hyper-V and whether they're candidates or not for replication. Now, it's worth mentioning at the moment, it's Gen 1 only. So those of you guys that are running Gen 2 machines, support isn't there for it yet, although it's this year. I know they're working on it and it's something they're going to get out very, very quickly. So once we've identified the VM that we want to use, our massively critical VM, we go ahead and, like any other replication technology, we make a copy of it and put it into Azure. And we have a replication schedule where we can say every 15 minutes, do a replication of the changes, and I might want to keep 8 of those. So you get the idea. You have to work out what's best for you. So in the event of that on-site machine, the one on the left there, failing, what we can then do is nip into our Azure console and we can tell the machine's failover. It's about 7 minutes we found. From the minute you press the button, 7 minutes later, then we can see all the acknowledgements from the Azure console and we can go in and see that machine running again. So that's what I want to show you. That's what we're going to try and get going. So to do this, I've created a 2012 R2 server called Server 1. Okay, 172.10.10.200. So that's an on-premise server. We've got that running in our innovation center. Okay, so I'm now going to go and kill that off. There we go. That wasn't me. There we go. So I physically switched it off. If I go and ping it now, it's dead. Okay. Now I'm not going to do much more than that apart from switch it off because for this purpose, that's good enough, I would say. And now what we're going to do is we're going to nip back to our Azure management console and let's go and take a look at performing a failover event. So we'll go to our recovery services and my site recovery vault that I've created is called MCL failover. Okay, and there's a dashboard sort of tells me what's going on. I can see I'm protecting one virtual machine. It's worth mentioning also that the Azure site recovery platform can replicate between 2 on-premise data centers as well. It doesn't have to go into Azure. You can use Azure as a coordinator for replicating VM1 from site A to site B. You can do that if you want. Okay, so once you've hooked everything up, what you will see, in a second, is our virtual machine that we've already got up there ready to go. So it's called Server 1. The important thing to remember when you're failing this over is that the networks must match because, of course, this machine can be restored to anywhere you like in Azure. So I've made sure that my network mapping is set to West Europe. That means when this machine gets restored to that West Europe data center, it's already on my network that I've got configured between on-premise and Azure. It will automatically get the right IP address and it will automatically have access to the DNS servers back at base. Okay, so let's hit the failover button and I'm going to do an unplanned failover because we didn't know this was going to happen and it's going to ask me what do I want to do. So I'm going to fail from the Medhurst Innovation Center to Azure. I'm not going to bother shutting the virtual machines and sync the data because, of course, we've lost the server in this instance. And we're going to click OK. All right, and I'm going to leave it at that because it's about 7 minutes, so I'm going to go and sort of show you some other things, but what we'll do later is nip back and we'll do an IP config flush DNS because obviously the IP address of this server is going to have changed and we'll see it running in Azure. Okay. Anybody got any questions so far? Okay. Oh, yes, sorry.
Do you need a VPN connection?
No, you don't. No. For this, again, it's done over an SSL connection, so you don't need it at all. Right. Where did we get to then? We are now going to talk about Operations Manager. So, using Azure for external infrastructure monitoring. So, a lot of guys here have used, a lot of you guys have used Operations Manager before. Operations Manager has been around for a very, very long time, and it's part of the System Center suite, and it's there to look after your servers, your switches, essentially anything with an IP address. It's very simple to use, but can be incredibly complicated to implement. If you're thinking of implementing Operations Manager, don't go and install all the management packs for all the different products because you'll be cursing yourself as soon as you do it. Pick a product like DNS or Active Directory, install the support for that, let it find the problems, go ahead and resolve them, and then install your next thing. So we know in Azure now, we can fire up all sorts of stuff. So for Operations Manager, we need an SQL database. and we need a management console with System Center installed on it. So essentially 2 VMs, all provisioned from Azure. I haven't had to supply any software for this apart from the Operations Manager ISO from Microsoft. We've already got a network connection in place using our Azure VPN site connectivity back to our school network, and as a result I can now start to manage and monitor and have insight into all of these different sorts of technologies. Okay, and I can manage it all through a very familiar interface. All the System Center products are based on a sort of an Outlooky look and feel, so they should be pretty familiar to people. Okay, SMB multi-channel. Right, this is really, really important. Now, back in the days, or before 2012 R2, let's say we took 2 servers and we wanted to have them communicate. If they had 10 network cards with an IP address configured on each card, they're only ever going to use one of them to communicate. Okay? No longer the case. If a server can communicate with another server on more than one network card, it will do now. It's as simple as that. So if we move that into the VM world, to communicate with a couple of VMs, each VM will need a network adapter. We'll go ahead and assign IP addresses to those adapters, and we can establish connectivity and start transferring files. And then, as you could imagine, to make SMB multi-channel work, you have more network adapters, you give them different IP addresses, and you have connectivity as you would expect. So things like live migration, which is a technology used to move VMs from one Hyper-V host to another, can make use of SMB multi-channel now. So you don't have to go down that 10 gig route to get blisteringly fast live migrations now. You can aggregate 3 or 4 NICs to give yourself a pipe, and then you can use SMB on the live migration itself. Makes it a lot quicker. So I just wanted to mention that. Not many people knew about that, and if you know, you did from PowerShell a get SMB multi-channel connection, it'll show you when you're doing a file copy which IP addresses you're talking to on the servers that you're trying to get the data off. So bearing in mind, very important, there's some really good technical articles on how it works, which I can give you after if you want, but it's a really useful technology. Okay, file services. So very quickly, let's just review how we share files with our clients, and then we'll move on to seeing how we can make that resilient using shared VHDX clustering. Okay, so at file server 1, we've got a VM here, and it's going to need a VHDX or a VHD file for its virtual hard disk. Okay, so we go and create one of those. It's probably going to be running Windows. In fact, this one will be running Windows, and then we attach it to the VM. Bring the VM up, configure it, give it an IP address, and there we are, we have a file server. Now, to actually share things on the network, typically we add another volume, like a data volume, so we've gone and created a data.vhdx file, probably your D drive or whatever drive letter you've given it, and then we attach that to the VM, okay? And then on that data VHDX file, or the data drive, we can then start creating our shares and putting data in there and making those available on the network. Okay, pretty normal, straightforward stuff until our file server fails, and as a result, what goes wrong? Pretty much everything. We lose those services that were available to us because that virtual machine has a problem for whatever reason. What can we do to sort this out? Well, this is where shared VHDX, so VHDX is virtual hard disk, the X is 2012 extension now, so 2012, 2012 R2 use VHDXs by default. They have far better error checking. You can go bigger than the 2 terabyte mark now, which you couldn't on VHDs, up to 64 terabytes, I think. It should be big enough for everybody. So let's start looking at how we can use this. So we have the same sort of thing again. We still have a file server. It still has an operating system disk. It still has a data disk, and you still have your shares and your data within that. Now, I've drawn a little SAN underneath there just to illustrate that these are files that represent the disks on this virtual machine. And really, those files should be stored on a platform that's resilient, something like a SAN, something that has multiple paths to get to it and can support disks failing without data loss. Okay? So it's important to sort of recognise that that infrastructure, best practice, should be beneath this in the first place. It's not going to protect us against losing a file server, but it does make sure that your data is well protected and can sustain the loss of disks. To cluster then, we're going to introduce another VM, so we're going to call this file server 2. And again, this VM will need a hard disk. It'll have Windows installed in that hard disk. That's connected to the VM. Now, instead of going to create another data volume, what we're going to do is we're going to connect file server 2 directly to the VHDX that we're using as our D drive on file server 1. Okay? And that is using a little bit of a little tick box there called Enable Virtual Hard Disk Sharing. So when you look at the properties of your VM, you scroll down to one of your hard disks, there'll be a little plus icon next to it, to the left of it. If you click that, there's an advanced features, and that's where you'll find it. And for every machine that requires access to a virtual shared disk, you must tick that button. If you don't tick it for one machine when you've done it for 3 others, you'll get an error. Okay, so what happens now if we lose a file server? Let's see the end result of this configuration. If you lose that same file server now, what actually happens on the network? Well, really not very much. Okay, you've lost your file server, and it's lost its C drive because the file server is no longer running. Has it lost its D drive? Well, it's lost its connection to the D drive because the server's now off, but the D drive is also connected to file server 2. And that means that the volume is still owned by a cluster node, the data is still accessible, and people carry on working, okay, through that failover process. So that's what we're going to show. That's what we're going to do, okay? We'll nip onto the platform again. And I've got a couple of servers here. I've got FC1 and FC2, appropriately named. And I'm going to log on to them both. Okay. So if I do a get disk at the moment, I've got a couple of disks, I think, in these file servers once they wake up. So I've got my C drive, and I've also got a little 1 gig shared VHDX. When you're building a file server cluster, if you've got 2 cluster members, you need something called a witness disk. It's like a third cluster member, if you like. So that's what that 1 gig disk is doing. So now I want to make this available. I want to add more storage to it that can be shared by my 2 file server clusters, and I want to put that data on the network. I want to be able to share, see my shares, start using them, and see what happens when I lose a file server, and that's what we're going to do. Okay, so the first thing we need to do, we're going to nip to failover clustering, and I'll just show you where I've stored this disk. In our cluster shared volume, I've got a folder called cluster VHDX. There's that witness disk I was telling you about, and I've also created a VHDX called public, and that's where our data is, and that's what we're going to be sharing via clustering. So, quite straightforward to do then. So we're going to go to the first cluster node. We're going to look at the settings of this server here, and I'm going to go to my SCSI controller, and I'm going to add a hard drive. Okay, I'll click add. Now I don't need to create one because I've already got that, so I'm going to hit browse. I'm going to go to the area in which I created it, the public VHDX there, and then before I do anything else, I'm going to expand it, advanced features, and enable virtual hard disk sharing. That's the magic button. Okay. Then I'll click OK. Does it say it's already connected? There we go, I did 2 of them. Right, so there we can see virtual hard disk, and it's connected to that particular server. We do the same thing for file cluster 2. Notice I've got these machines on while I'm doing this, so these are the Gen 2 machines, and I can go ahead and add my hard disk, remove them while the machine's online. Actually, I'll rephrase that. You can add cluster disks while the cluster's up. To remove them, you have to take cluster nodes down to remove them. So again, what we'll do, we're going to browse to that file. We don't need to add a new one. We don't need to create a new disk. We just need to browse to that public drive that we've used on file cluster number 1. Advanced features. I won't tick it, and I'll hit apply, and you'll get an error. Okay, there we go. It's saying, well, actually, I can't do that because it's a shared disk, and you're not telling me to be in shared mode. So as soon as we go to advanced, tick that, click on OK, and it takes it for you. So now, file or FC1 and FC2 are connected to that public disk. They both have a connection to it. So if I go back to one of the cluster nodes, we do a get disk again, there it is. I've got a 3rd disk. So if I just bring that online, and I'm going to go to, sorry, my apologies, other server. It's already in the cluster, I've already done it for you. So we're going to bring that online now. At the moment it's on file cluster member 1, and it's sitting there. I can move that around, so if I wanted to, I could move it to a different file cluster, so I can move that storage around. Don't forget, that's how clustering works. You have disks that are owned by the file cluster nodes. So if a file cluster owns a disk and the file cluster fails, that disk is then owned by another file cluster node, and that's how the service is maintained. Okay, so I've now got my public disk, it's available, and I want to now create a file server role in my cluster. Now it's worth mentioning that this cluster is called files.school.lab. This is basically what you build when you're doing your Hyper-V failover clustering. Instead of putting Hyper-V virtual machines in here, we're putting something else in this case file servers. So I'm going to configure a role. I'm going to come down to file server role. Okay, I'm going to just have a general use file server. You can have something called a scale out file cluster, which is meant for things like SQL, Exchange, and Hyper-V. Okay, so this is very highly available. This does, if you lose a cluster member in that scenario, the volume carries on running, so you can realistically run hypervisors, virtual machines on there, and high I/O workloads. We're going to use a file server for general use because we want to take advantage maybe later on of things like quoting, file server resource manager. They're all supported on a general use file server. Okay. So we need to give it a name, so I'm going to call it staff, for example. It's going to create an Active Directory account for that. We're going to need an IP address for that particular name. That will go on the network. And then it should ask me, what storage do I want to associate with this file server role? And there's our disk that we connected up to both file servers. I'm going to use that. Click on next and we'll click on finish. And there we go. We're now bringing that cluster up or cluster role up, and it's succeeded. So you'll see in a moment, the file server role is starting. At the moment, the owner node is FC1, okay, file cluster member 1. There we go, so that's up and running now. So the next thing to do is to start using it. We need to go and, create some shares and get some data on the wire. So in order to do that, wait for it to load up quickly. I'm going to go to shares, and I'm going to create a file share. Okay. I'll be quite straightforward with this. I'm not going to do anything particularly clever. I'm going to do a quick file share. Okay. I'm going to have a custom path. I could select the whole drive. I could do a number of things, but I just want to use a folder on that E drive, which is what it's come up as, and I'm going to use the staff public folder there, and that's the folder I want to share out. I'm going to keep the name of staff public as my share name, and I've got some additional options there if I want to use them. Things like continuous availability is one of the things that we do want to use. I'll explain that when we look at how we can fail over a file server. Okay, I can assign permissions, do the usual NTFS and share level stuff that you'd normally do on a share. I'm going to leave it all as default. And there we go. So I've now created a clustered file system. And to test that, we need to sort of see how things fail over. Now, to speed things up with failover, there's one thing I'm going to do. By default, NetBIOS is enabled on the IP address of your file server cluster, which means that you've got all sorts of broadcast things going on when you take or when you move a resource from one file server to the other. So in order to sort that out, we're going to nip in there and we just turn NetBIOS off for that particular IP address. It'll want to restart the IP address for that staff file cluster. It'll restart it. Everything's back online. We're ready to use it. There we go. So from a client's perspective, I'm going to nip over to this machine over here. And I'm accessing this now from a machine that's completely separate to my Hyper-V environment. Still a domain member, but I want to go and have a look at that particular share now. So let's dip into the staff share or the staff server, because don't forget that a cluster puts a server onto the network. You access that server and the shares are on the back of that. Okay. And I've got an ISO in there, nice big 4 gig ISO of Windows Server Data Center. And I want to use that at the moment. So if I copy that, I'm just going to paste that to my desktop. Okay. And then we're going to do something pretty ruthless. So we know that at the moment our file cluster is running, or that particular role is running on node 1, file cluster 1. Let's just go in and check that. There it is, file cluster 1. So what I want to do is turn off that file cluster member. We're actually going to completely bin it. So file cluster 1, turn it off, and then let's get back to that machine that was doing the copying so we can see what's going on. Now you can see the I/O stalled now. We're not actually doing any copying. That's because there's a failover process going on. And that's pretty quick. So now node 2, whichever other cluster members there may be, are taking hold of that volume, and I/O will start flowing as soon as that volume is owned by that second cluster node. Now it's also worth mentioning that this SMB failover uses something called transparent failover, and that's another new feature. There we go, we can see it working again. Now from an applications point of view, if you didn't have this and you were to kill that cluster member, the application would say, well, I can't see my data anymore, and it would stall, or it would actually physically crash. So SMB transparent failover, which is what you've just seen, is supported on Server 2012 and Windows 7 upwards. It allows the application to be, if you like, stopped or controlled by this SMB transparent failover, which means that the failover piece is telling the application, hang on, it's okay, hang on, it's okay. And the application's sitting there going, okay, I'll hold on. And then the I.O. starts flowing. The application sees that as a stalled I.O. event rather than a failed I.O. event. So very, very useful. And you can see how quick that was. You know, if you did have that file cluster fall over at school or a member fall over at school, I mean, the phone's not even going to ring before people get access to their work again. It's going to be very, very quick indeed. And you can support up to 64 nodes in a file server cluster, I believe. Okay, right, I'm nearly done. What I wanted to do very quickly then, a couple other things to tidy up. Let's just go and have a look and see if our failover is complete. I'm not even going to go and check, actually. I'm going to assume it's worked. I'm going to do a flush DNS. So, I will when I can spell it correctly. Okay, so if you remember the file server IP address before, or the server, remember server -1 was 172.10.10.200. Moment of truth. Ping it now. Look at the IP address now, 192.168.10.7, and that's in Azure. And you saw, all I did was turn that server off on my on-premise. I went to my Azure console, said, fail that over to West Europe, please. And I'd imagine, I mean, I don't know how long I've been talking for, but I measured it last night at about 7 minutes. And there you go, that's how you can, that server is now available again. Okay, you've got to bear in mind that instead of being connected to that building with a gig, you're connected to Azure with 100 meg, or a gig, or 200 meg. And then you can then take advantage of that platform in this manner. Has anybody got any questions? No? Fantastic. Okay. Right, if there's anybody that wants to talk about any of this at lunchtime, what we're going to do now is hand over to Richard and Scott, who are going to do a little bit about the Medhurst dashboard. But if anybody wants to sort of grab me at lunchtime, or these guys on the piece they're about to do, please feel free. But thank you very much for coming and listening. Thanks a lot.